Hello, my name is Katsushino Wara. Thank you very much for visiting our research project. Earthquakes are underground fault drift phenomena. In subduction zone, oceanic plate is always descending, associated with dragging the continental plate, and strain is accumulating at the plate interface. When the strain builds up to the limit, usually a rapid sliding occurs and generates ground shaking. This is an ordinary earthquake. However, recently, unusual earthquakes, so-called slow earthquakes, were discovered. Slow earthquakes are caused by slow sliding, which results in no shaking or very slow vibrations. Such slow earthquakes have been found by seismological and geodetic observation networks deployed throughout Japan in the end of the 20th century, then began to be observed in other regions of the world as well. In order to understand why, how, and where occur slow earthquakes, we conducted a 5-year project, Science of Slow Earthquakes, as a grounding aid for scientific research on innovative areas supported by MEXT and JSPS. The material conditions and physical laws governing slow earthquakes are expected to differ from those of ordinary earthquakes. To tackle and unravel the mysteries of slow earthquakes, a multi-faceted approach combining geophysics, geology, and physics is necessary. We organize nationwide multi-phased research groups centered on the Earthquake Research Institute, the University of Tokyo, to clarify the activity characteristics, environment, and occurrence mechanisms of slow earthquakes. Throughout the 5-year project, we published many scientific papers, newsletters, and pamphlets for public. We frequently organized many international workshops on slow earthquakes in and out of Japan and collaborated with overseas researchers for joint offshore observation. As one of great results, many types of slow earthquakes have been discovered in such a way to fill gaps in space and spectral domains. For example, many long-term slow slip events were found to fill the gap between seismogenic and deep tremor zones. In offshore area, shallow slow slip events were newly detected by pressure gauge associated with shallow tremor and shallow very low frequency earthquakes. Based on stacking method, we found slow earthquake signals as a spectrum gap between tremor and very low frequency earthquakes. As a result, we recognize that the slow earthquake has a broadband spectral properties, and composition of slow earthquakes in shallow and deep flats is common. On the other hand, more quantitative and comprehensive analysis revealed more heterogeneous activity pattern of slow earthquakes rather than homogeneous. That's all for my presentation. Thank you very much.